This is a question about some chemistry and thermodynamic properties of group 17 elements, the halogens. We are given three processes here. The first one is about the enthalpy change of this reaction. Hydrogen halide composes to hydrogen gas and halogen gas. Second, it's about Kp of this equilibrium. Hydrogen reacts with halogen to form hydrogen halides. The third one will be ionization energy of different halogen. Both HCl and HBr undergo process number 1. Statement 1 says that enthalpy change of reaction for HCl is higher than enthalpy change of reaction for HBr. I'm going to write down the equation for HCl undergoing this reaction. To calculate the enthalpy change of reaction for this process, it would be the sum of all the bond energies of bonds broken minus the sum of bond energies of all the bonds that are formed. For HCl, it would be 2 times the bond energy of HCl bond minus the bond energy of hydrogen-hydrogen bond and the bond energy of Cl-Cl bond, because all the HCl bonds will be broken before they can form the products, and all the bonds in the products H2, Cl2 are formed in the reaction. Breaking of bond is endothermic. Formation of bond is exothermic. That is why the sign positive and negative in this formula. Next, I'm going to write the same thing for HBr so that we can compare after this. I've written the equation to calculate delta H of reaction for HBr. Going down group 17, hydrogen halide bonds is getting weaker. Because the bond lengths are getting longer going down the group, so the bond energy will decrease going down the group. Whereas for the bond between the halogen atoms going down the group is getting stronger. That means bond energy is increasing going down the group. The reason is because the area of overlapping between the atomic orbitals become larger, so that makes the bond become stronger. So now coming back to comparison between the two enthalpy changes, I'm going to put some hypothetical values for these bond energies so that we can come up with a value that is easier for us to compare, a more tangible value. We have hydrogen bond, which are in common for the calculation for both enthalpy changes. So let's say this is 100. The bond energy of HCl should be a larger value compared to the bond energy of HBr because it is decreasing going down the group. So I'm going to use a larger value here and a smaller value for HBr. Now, X2 bond energy for Cl-Cl, it should be a smaller value, Br-Br a larger value this time. So I've assumed that the bond energy does this value according to the trend. Now I'm going to calculate a value for these enthalpy changes. So by using some hypothetical values, I was able to calculate enthalpy change of reaction for HCl and also for HBr. And now I can compare them. For HCl, 650 is higher than the value of HBr, 430. So this statement is correct. So in the exam, you could also use the same method. We do not have the actual value, but you can put in some hypothetical values so that you can use them to make comparison. Statement 2 says that Kp for HBr in process number 2 is higher than the Kp value for Hi in process number 2. Again, I'm going to write down the two equations for both HBr and Hi in process number 2. Now I'll write the Kp expression for both of them. Both the Kp expression show us that the Kp value will be larger if the partial pressure of the products is higher. So now we compare these two equilibria. For formation of HBr, equilibrium lies much further to the right-hand side. For Hi, the equilibrium lies further to the left-hand side. Now the reason is because HBr bond is stronger than Hi bond. So HBr needs more energy to decompose into hydrogen and bromine gas in the backward reaction. For Hi, the Hi bond is weaker, so the backward reaction needs less energy. Hi is easier to be decomposed back to H2 and I2. Equilibrium lies further to the right-hand side. Partial pressure of products is higher. Equilibrium lies further to the left-hand side. Partial pressure of product is lower. So Kp for HBr will be larger than the Kp of Hi. Statement 2 is correct. Statement 3 is about the ionization energy of iodine and chlorine. In group 17, iodine is below chlorine, so the atomic size of chlorine is smaller than the atomic size of iodine. Nucleus is in the middle. Chlorine's valence electrons are closer to the nucleus compared to the valence electrons of iodine from the nucleus. Further away the electrons from the nucleus, weaker is the attraction between the electrons and the nucleus. So comparing these two, iodine needs less energy to remove its valence electrons to form a cation. So it has a lower ionization energy compared to chlorine. So for statement 3, ionization energy for iodine is larger than ionization energy for chlorine is incorrect. Therefore, the answer to this question will be B.